Hi guys, I'm back with another question for the placement series. So now I'm going to discuss about something called as the Fibonacci series. So Fibonacci series is a mathematical function which can be described as for a number n of the Fibonacci series can be can be derived using the summation of its two preceding numbers. So it can be defined as Fibonacci of n is equals to Fibonacci of n minus 2 and Fibonacci of n minus 1. Okay, so how do you think the series would look like? This function has two uh, say base cases such that the zeroth element and the first element is always 0 and 1. So that is how the series start, and any Fibonacci series of any number will always have 0 and 1 as its first two elements. And then for the next element we have to add its two previous elements 0 and 1 and calculate the summation. We get 1, so that's our next element. And for the next element we have to repeat the same thing. The previous one is 1 and its other previous one is also 1, so we're gonna get 2, and similarly we'll get 3 and then we'll get 5 and so on. So this happens till whatever the number that is required. So so to create an algorithm or to write a program for this kind of series, so what are the steps that we need to follow? So it is already given that we need to consider two base cases, which is these two values are going to be fixed with 0 and 1. So what we can do, we're gonna use two variables, let's say a and b. And before actually creating a loop, we first going to assign a to the value of of 0 and b to the value of 1. Now, so we need another variable to actually hold the next value, which is the addition of a plus b. So I'm going to use c as a variable. So c will now have the value which is a plus b, that is 0 plus 1, 1. So after the end of the first iteration, we may print we can use a as a main variable to print on the console. So this is our console output. In the console output after the iteration 1 we'll have 0. Okay, in iteration 2, what are the updates that we're gonna do? So let us look at the updations. So we're gonna make a to be b, and b will have the value c, and as we know c will have the value a plus b. It will have value a plus b. Okay, so how are we updating? Okay, let's see. A will have the value of b, so a will become 1, and b will have the value of c, so b will become 1, and c will have the updated sum of a and b. So I will see as c should be written here. Okay, so c is going to have the updated values of a and b, and it's going to perform summation and get the value of 2. And then in this iteration, again on the console we're going to print the value of a, that will be 1. And for the next iteration we'll do the same thing. We'll have a as b, which is 1, and b will have the value 2, and c will have the value 1 plus 2, which is 3, and it's going to continue, and we are going to print the value 1, and thus we can create such series. So let us write a program in the Python language to see how this actually works. So let's define script. Okay, let us take an integer input from the user, and let's write a prompt like enter a number. Now as we have discussed, we need two variables to store the base cases. So a will have the value 0, and B will have the value 1. Okay, now so we don't know what should be, when should we stop. So we're gonna use while loop, because when you don't know the number of iterations, we're gonna use while loops. So while n is greater than 0, or we can define it another way, but let's do it this way. While n is greater than 0, what are we going to do? We are going to print the value of a. Let's use space, or we can say the star and equals to space. Now we need to calculate c, which is equals to a plus b, and a will point to b. Let's see what's happening. And a will point to b, and b will point to c. And also, since we're using n, we need to decrement the value of n. Right. So let's see what do we get. So we'll be saying, let me enter 5. So we got the first 5 Fibonacci numbers. So, but if I want to modify the program in such a way that I don't want the number 5, but if I want the program to actually print numbers, I mean print Fibonacci numbers under a value. I want to see how many Fibonacci numbers are there in between 0 and 100, and how many Fibonacci numbers are there under 1,000, under 10,000. So then we can eliminate the statement and say while n while a is less than n, while a is less than n, I am going to do this. So when a reaches the value, the threshold that we have set, then it's not going to print. So now let's run this program, and if you say 5, it's going to print a Fibonacci numbers up till 5. It's not going to use 5. If you say I want to see what are the Fibonacci numbers under 100, so these are the Fibonacci numbers under 100. We can do the same for 1,000. Let's skip 1,000. Okay, so you see that there's not a lot of numbers in this series, so it is an increasing series, so the numbers are going to be declined. So this is the basic idea behind writing a Fibonacci program. So this is what a basic of a Fibonacci would look like, but this is not considered the most optimal, because the loop that we are using, it's going to take order of n, and it is an iteration based algorithm. But there's also another way that you can write Fibonacci, which is you can use something known as recursion. You can, by using recursion, we can also solve this with and recursion is a more intuitive way of understanding what happens with Fibonacci. So let's say that you need to find the Fibonacci f of 5. So let's say we need f of 3 actually. So how do we define this function? F of 3 can be defined as summation of f of 2 and f of 1. Right. So when I have this value of f of 2 and f of 1, I just have to add it to get f of 3. And similarly for f of 2, what should I do? For f of 2, I have to get the f of 1, and I have to get f of 0. And for f is equals to 1, we're going to check for f of 0 and f of -1. So can you find out, so can you see something that's wrong see f of -1. See, if we are going to do this, it's gonna be in a infinite loop, because uh, uh, we will keep on calling for all the negative numbers, so we have to stop at some place. So we know that the base case for the iterative approach is, I'm gonna say the 0th value is going to be 0, and the first value is going to be 1. So we're gonna assign f of 1. F of 1 should only return 1 irrespective of whatever it is, and f of 0 always have to return 0. So how can you do this case? So I think we need to write, so this is actually the general case, like f of n is equal to f of n minus 1 plus n minus 2 will be the general case, but the base case would be if this n, the n which is the argument inside the function, if it is 1 you have to return 1, if it is 0 you have to return 0. Okay, so we have understood how this works, uh, and also try and understand how we are getting the answers. So from the top, uh, 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 we are breaking down this main problem into two subproblems and again two subproblems, and at the leaf we are getting results. So this is a top-down approach. We can also use something known as a bottom-up approach, in which we can get to f of 3 by actually using values 0 and 1, and building upon it we will get 1, and building upon 1 and 1 we can get 2, and building upon 1 and 2. So we can also use this approach. So let's see how the first one looks like. So we'll keep it the same, and I'm going to define a function. Let's not use this. It's going to take an argument. So the general case would be, it has to return, okay, if n is less than or equal to 1. So I'm not gonna write these two cases like 1 1 and 0 0. I'm just gonna say if it's less than 1, you will just return 1. I will just return n. So what if it is 1, we're going to return 1. If it is 0, we're going to return 0. So all the cases are covered. And if it's not the case, if n is indeed greater than 1, then we can use our general case, which is Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is all the function that we need. It's just a single if else block. So now let's take an integer n, and let's call that function fib. Now let's run this and see if we have any issues. So let me enter the same number that we started, 5. Says we got some errors, unsupported operands for none type. Okay, so we didn't return, so it's an issue. Wait, we didn't return this, and after returning we're not printing the Fibonacci, and let's print this and see what the error was. Okay, let's run this again. Let's give 5. Now I'm getting 5, but is that what we wanted? We wanted to print everything, right? Okay, then how can I print every Fibonacci number in this way? So instead of return, can I say you just want to print this? No, it will always print whatever the number that we got. So I think it will only give us number, but where is it for 100? Okay, it's going to take long because we are using recursion, so there will be a lot of system calls. I hope it's not in a loop or something. Okay, stop this. Doesn't seem to be a great idea. Let's give something like 10. Okay, it's 55. So it's working, but we're only getting the last Fibonacci value. But I wanted a series. How can I print a series? Okay, a silly approach is to just call this for n number of times. And okay, let's try and run this. Let's give me the answer 5. So let's run this code and let's say 5, and yes, we're getting a Fibonacci series up to 5. Okay, let's try this with 100. Yeah, probably so you can see this is not a very optimized algorithm because it takes a lot of time to print just the 100 Fibonacci number series. So this is because it is using a multiple calls, and it is making uh, a lot of redundant calls as well. So is it making redundant calls? So let us try and understand what's happening under the. So let us stop this. It's not a great idea. Let's ask for a 10, which is easy. Yeah. So this is for this program. So now let us just kind of see why is it very slow? Why the recursive approach is very slow? Okay, so let's let us try and trace what is happening. If we say for 5, if for Fibonacci of 5, we are calling Fibonacci of 4 and Fibonacci of 3. For the Fibonacci of 4, we're calling Fibonacci of 3 and Fibonacci of 2. For 3, we're calling 2. For 3, we're calling 1. But one will return you easily, and 2 will call 1 and 0. So these are my base cases, and 2 will again call 1 and 0. 3 will again call 2 and 1. 2 will again call 1 and 0, and 1 is a base case. So we have our base cases 1 0 1 1 0. So these are all our base cases. When we reach here, we're just going to return the value that we get, either 0 or 1. But just try and understand what's happening with this. Okay, we have already computed this, the a Fibonacci of 2 value. So we know what f of 2 is going to return when we are going to call it. But again, in this case, we are again we are again calling a function, and it's again going through all of that, and it's not remembering its past values. So and also here for 3, this entire thing was 3. Here this entire thing was 3. So I'm making such calls, so it's going to make the program very slow. So how can I so what can we make to change that? So if there is a possibility of me storing a value, maybe keeping an array with indexes 0 1 2 3, like this is the nth Fibonacci number. So if I could store the value of f of 2 here, so if I can store value here, so whenever I'm going to call the same function again, I can check in this array that is it present in my array, or in my the we usually call this as a DP array, because the kind of algorithm that we are using for this is called as dynamic programming. So we're going to check in this array if this value is already pre-computed and already present with us. If it is present, then we can use this. So using this will completely eliminate all this computation, and same goes here, and also for the 3. So if you observe, it actually became an order of n solution because we're only calling for only the unique set of values of Fibonacci. So by using a tree, it is using extra memory and extra calls, but in this way, it's taking up a very, you know, a little amount of resources. So this is the most optimal way of using recursion. But anyway, the reason that we use recursion is just to keep the code look so simple and easy to understand. But the iterative approach always is going to be the winner in terms of speed and the performance. Yeah, so this is all about Fibonacci, I think. So we'll meet in the next session with another program.